In this problem, we are asked to use the shell method to find the volume of the solid of revolution made up by y equals sine x squared, x equals 0, and y equals 1, and it is revolved about the y-axis. So if we were to consider what we're looking at, x equals 0 is the y-axis, y equals 1 is this horizontal line, and the sine of x squared from 0 to 1, or from 0 to 1 on the y, is doing something like this, and the x value, where these intersect, is the square root of pi halves. So a couple things to note is because we're dealing with a trig function, we have to be thinking in terms of radians. So this is our space, and we are revolving about the y-axis, which means that our shells expand in this direction. Our shells have a height and they have a radius. So since our shells expand in that direction, in the horizontal direction, we will be integrating from 0 to the square root of pi over 2. And this is times 2 pi. I'll do the radius of our shells in red. So any random shell, let's say we have a shell here, its radius will go from the axis of rotation to where the shell is. In this case, the radius is x. The height of the shell, the height of the shell is here, and that is equal to 1 minus sine of x squared dx. I'm going to integrate using my calculator, so I will have this be y1, and so I'll do 2 pi times math 9 will give me function integrate of y1, and again y1 comes from vars, y bars, choose function, y1. I want to integrate with respect to x from 0 to the square root of pi divided by 2. When you do this, you get this decimal value, 1.793, and if you compare that with the answer to in the back of the book, which is expressed as 1/2 times pi squared minus 2 pi, this is what you get if you integrate by hand. This is equivalent to 1.793.